In this lesson, we're going to talk about rate of change and its application in the real world. Let's look at this first problem. You're doing a 5,000 piece puzzle, and you have already placed 175 pieces. Every minute, you place 10 more pieces. First thing we want to do here before we start answering our questions is we want to define our variables. I have an independent variable, x, and I have a dependent variable, y. It looks like from this situation, I have numbers of pieces placed, and I have minutes. Anytime you have time, that's minutes. So I'm going to go ahead and label my x as my minutes. And my y is going to represent my pieces placed. Now that I know my variables, let's answer the question A. Write an equation in slope-intercept form to model the number of pieces placed. So, the number of pieces that I place is equal to, it looks like it says I've already placed 175 pieces. So let's go ahead and write that down. But every minute you place 10 more pieces. So for every minute, I'm going to place down 10 more pieces. So I'm going to say plus 10 times every minute. Now, I know this isn't in slope-intercept form, so let's go ahead and transfer that. Y is equal to 10x plus 175. This is saying that I've already placed 175 pieces down. That is my y-intercept. That's my, we like to call it a flat rate. It's something that's in place and it's not changing. But then, the thing that is changing is I'm going to place down 10 pieces per minute. So my x is going to be the number that's next to my slope. So y equals 10x plus 175 is my slope-intercept form that models this situation. Now, B says after 1 hour, how many pieces will have been placed? So I'm going to go ahead and I'm going to substitute a number into my x. Now, 1 hour. Again, my x is in minutes. So 1 hour is actually transferred into 60 minutes, right? So I'm going to substitute 60 minutes in for my x, my minutes. So 10 times 60 plus 175. And then I can go ahead and simply solve it. 10 times 60 is going to give me 600 plus 175. So my y will end up being 775. All right. So now that we have found our equation, and we found how many pieces that would be placed in 1 hour, I could also ask multiple things here. I could ask, how many pieces were placed after 3 hours. I can ask multiple questions for this type of problem, but let's go ahead and stick with what we have. Okay, let's look at another one. Let's look at a sailboat. Okay, a sailboat begins a voyage with 145 pounds of food. The crew plans to eat a total of 15 pounds of food each day. Okay, I have two variables. I have an x and I have a y, my independent and dependent. I like to start with my independent, and I ask myself, do I have any variables that represent time? And in this situation, I do. I have each day. Day is time, right? So I'm going to represent my independent variable by days. And my y looks like it's going to be pounds of food. Okay, now that I've represented my variables, let's go ahead and answer the questions. Write an equation in slope-intercept form relating the remaining food supply y to the number of days x. And actually, if we read earlier, we were given these variables, but that's okay. We define them on our own. Okay, so I'm going to say y equals, I want to know, well, how much food is actually on the ship already? 145, right? And each day, the crew is planning to eat 15 pounds. Planning to eat 15 pounds means that you're losing 15 pounds of food. So I'm going to say minus 15x. But of course, this is not in slope-intercept form, so let's go ahead and write that quickly. So y is equal to negative 15x plus 145. This equation represents the food supply after X days. Okay, now let's answer some questions about this. The crew plans to have 25 pounds of food remaining when they end the voyage. How many days does the crew expect their voyage to last? So, unlike the last one, where we were substituting a number into the X variable and solving for Y, now we're actually doing the opposite. They give us that we have 25 pounds of food remaining. That's my Y. That's why it was so valuable to determine and define my variables. So I'm going to say 25 is equal to, now let's go ahead and write everything else out. Now I'm going to do some math here. I'm going to go ahead and solve for X. I'm going to do that by subtracting 145 from both sides. So 25 minus 145 is going to give me negative 120 is equal to negative 15x. And I'm going to go ahead and continue that. And divide by negative 15. My x is going to equal 8. Well, if I look at it in the context of the problem, how many days does the crew expect their voyage to last? Well, I would say that my answer would be 8 days. Okay, let's go ahead and take a look at two different types of problems now. Okay, after 30 baseball games, Bryce Harper has 36 hits. And after 100 games, he had 120 hits. Let's go ahead and define our variables. X and Y. Okay, so we have hits and we have games. What depends on what? Do games depend on hits or hits depend on games? I would say hits depends on the number of games that we play. So hits is going to represent our dependent variable. And the X is going to represent the number of games that we played. Okay. What is the statistical average for his number of hits per game? Well, statistical average, we're looking for the slope. So can you figure out 2 points represented by this problem? I see that I have 30 baseball games, and in 30 baseball games, Bryce Harper hit 36 hits. And then I can also see that in 100 games, he had 120 hits. So there are my coordinates. I have x1, y1, x2, y2, and I'm going to go ahead and solve for my slope. M is equal to 120 minus 36 over 100 minus 30. So 100 minus 30, or 120 minus 36 is going to equal 84 divided by 70. So my slope is going to be 1.2. So it looks like 1.2, and the way we would say this is hits per game. And that's actually very good for a batter who only gets up to bat about 3 to 4 times in a game. So that's actually a very good statistic. All right, let's look at B. Write an equation in slope-intercept form to model the number of hits. All right, well, it looks like here's y equals mx plus b. We have a slope, don't we? We have a slope and we have a point. So let's go and figure out our slope-intercept form. So I could go ahead and use my camel method, and I could do 120 is equal to my slope of 1.2 times 100 plus b. Remember, I'm solving for that b. So I'm going to have 120 is equal to 120 plus b. I'm going to subtract 120 from both sides, and that's going to definitely give me b equals 0. So if I were to write this in slope-intercept form, it would be y is equal to 1.2x. And you're probably thinking, wait, that's a direct variation. And you're exactly right. All right, now let's see what we can do here. 80 games is about mid-season for the Nationals. If he stays healthy, how many hits should he have by mid-season? All right, so mid-season is about 80, 81 games. So let's go ahead and test it with 80 games. Again, games is our x value, so we're looking for our y value. 1.2 times 80. And that will give us 96. So he should have 96 hits by mid-season if he stays healthy and is consistent at this same rate. All right, let's do one more problem that's an application problem. Oh, Apple stores. I love this one. There were 246 Apple stores worldwide in 2008 and 317 Apple stores worldwide in 2010. Let's go ahead and define our variables. I have X and I have Y. I personally like to ask myself, is there anything represented with time? And there is. It looks like we have time in years. So I'm going to represent that as my X, my independent variable. And then my other variable, my Y, is the number of Apple stores. All right, let's determine the rate of change in growth of stores. So the rate of change, again, that's another way to say what's the slope. So to find a slope, I need 2 coordinate points. So let's go ahead and see if we can find them. All right, it looks like in 2008, I had 246 stores. Make sure to place your X and Y in the proper place. Then in 2010, there were 317 stores. Okay, let's go ahead and say X1, Y1, X2, Y2, and let's go ahead and solve for my slope. 317 over 246 divided by 2010 minus 2008. Okay, let's go ahead and simplify this. 317 minus 246 is going to give me 71. And that's going to give me over 2. So if I simplify that down, my slope is going to be 35.5. That is going to be my rate of change. And what that's saying is it's going to be 35.5. I'm going to say stores per year. So on average, at this consistent pace, if it was a linear, linear data, there would be about 35.5 Apple stores opening per year. All right, now we want to write a linear equation in slope-intercept form that models the growth of the Apple stores. So let's just do what we did before. Y is equal to mx plus b. And let's go ahead and substitute what I know in there. So I'm going to go ahead and choose a coordinate. I'm going to go ahead and choose the first coordinate here. And I'm going to say my y, which is 246, is equal to my m, which is 35.5, times my x, which is 2008, plus b. Now you're going to find here that it's going to be kind of a big number. So 246 is equal to 7, 1, 2, 8, and 4. So 71,284 plus b. And you got it. I'm going to go ahead and subtract that from both sides, just like I've been solving these equations. So let's see what my b is. So 246 minus 71284. So my b is going to give me negative 71038. So put that all together. My slope-intercept form is y equals 35.5 x minus 71,038. You're probably thinking, well, why are those numbers so big, right? Or so small in our case with the negative. Well, let's see what happens here. If this rate continues, how many Apple stores should be functioning in 2020? 2020 is a year, right? So I'm going to substitute that in for x. So let's go ahead and take that equation and let's go ahead and substitute 2020 in for my x, because that is my x variable. And we do have some calculating to do, so go ahead and do that. All right, I'm going to simplify this down. That's going to give me 71710 minus 71038. All right, and if I simplify that down, y is going to be 672. Well, 672 what? Well, Apple stores, right? So in 2020, there should be about 672 Apple stores if it continues at this constant rate. Okay, the things to remember about these types of problems is, first of all, your variables. Defining your variables is very important at the beginning of the problem, especially when you're talking about time. Anytime you're given time, always consider that your x variable or your independent variable. And when you're asked to find the rate of change, be on the lookout for two coordinate pairs where you have your x as your independent and your y as your dependent variable in your coordinate pairs. And from there, you have all the skills to determine your equation in slope-intercept form.